Today we're going to talk about building Metro-style applications with C++. Just going to cover a few different topics. We'll do a little preamble. We'll talk about C++ CX, and I'll give you kind of a quick primer on the language. We'll talk about XAML in C++ and application building with XAML in C++. And then finally, we'll do a little bit of mixed mode projects with HTML, JavaScript UIs calling WinRT components that are built in C++. Who attended my session yesterday? A lot of folks. Okay, so I have exactly one duplicated slide, about half the crowd looked like. One duplicated slide, and this is it, because this is what I think is the most important slide. This is about why developers choose C++. So you have a lot of choices. If you want to build a Metro app, if you want to build any kind of application, you have a lot of choices in terms of programming language, library, whatever stack you want to use. As we work with C++ customers and we go, okay, so you have a lot of choices, why C++? And these are the three themes that really resonate. So wanted to share them with you and make sure everybody's kind of on the same page. First reason is closeness to the hardware, and there's a lot of manifestations of closeness to the hardware. One of them is the obvious one, which is performance. I write it in C++ because I need it to go fast for some reason. Now there are some apps that are not constrained by performance like that, and so you should use the highest level language you can get away with. But some apps are constrained by performance, and that's why folks choose C++. But it can also mean, hey, I need to control exactly how memory is managed. I need to control physical layout of structures in memory. I'm talking hardware, whatever. It's close to the hardware. Usually you do that because you want to either deliver somebody an answer more quickly, or you want to create an experience that is more natural feeling, more fluid. Second reason is cross-platform. How many folks build apps for something other than Windows in the room? Yeah, so maybe a third to a quarter of the room of folks building apps for something other than Windows. Fairly common theme, and that's again why people use C++. My latter example here is especially interesting because it shows JavaScript with C++. So that's two languages that work well multi-platform, targeting the Windows platform in this case. But mobile's a big deal here, right? If you're writing mobile apps, you want that code to live on Windows phones, maybe Windows tablets, maybe Android devices, maybe iOS devices, maybe Mac devices. If it's on server side, maybe you need Linux. And finally, there's compatibility. C++ is compatible with people's existing C++ code bases. It turns out there are lots of lines of C++ code in the world. And guess what? There's going to be more lines of C++ running in the world tomorrow than there are today. It just generally keeps getting bigger. And so when you have an application like that, it generally makes sense to continue to evolve it as a C++ application. It's also compatible with people's knowledge, people that have invested time and career energy in learning C++. They want to continue to leverage that investment. And finally, maybe a little bit less obvious, but C++ and C, more C than C++ in this case, is kind of the default interop language between two programming languages. So if I have programming language A, programming language B, how do they talk to each other? They use programming language C. They talk in C. So as we talk about Metro-style applications, C++ is interesting because it supports all three of the Metro application types. XAML, which we'll talk a lot about today, HTML, JavaScript, which we'll touch on, and DirectX, which we won't touch on today. But wanted to let you guys know it's there, that you can build DirectX applications, and you can even build hybrid DirectX XAML applications with C++. There's designer support in the product now, so for kind of the first time in a long time, I think the C++ language is on equal footing with other languages in terms of being able to use modern design tools to design applications. And people tend to choose C++ in this domain if they need the power, if they need to be close to the hardware, or if they have components that they need to be cross-platform. This is the famous Windows 8 stack slide, and the only reason why I'm showing it here, I'm sure many of you have seen it, is I kind of wanted to do the "you are here" map like the mall. So this doesn't have a laser. Oh, it does. Ooh, look. Ooh, are you guys still here? I'm like a cat now with this laser pointer. So we're going to spend a lot of our time right here. We're going to spend a little bit of our time using this and kind of interoping with some C++ WinRT. That's where we'll focus our attention today. If you look at building metro-style applications, now one of the things I won't cover today is like all the ins and outs of what does it mean to be a metro-style application. You can get that information somewhere else, and that truly warrants its own session. There's a lot to know and understand there. So I'm going to assume like you either have that knowledge or you can kind of suspend disbelief long enough to go through what it means specifically to C++, rather than generally about metro style. But starting, we've got a bunch of templates, and I'll show you some of the templates. From the design process, we have two designers. We have the Blend product, which comes with Visual Studio, and I'll show you what that looks like and how to invoke it from within Visual Studio. There's also a XAML editor within Visual Studio that's a little bit more limited, but kind of for basic needs, it works really well. For coding, you kind of get all the cool coding stuff that you would expect. You get IntelliSense, you get object browser support, you have all the item templates in the IDE. We use the C++ CX language extensions to bind to the WinRT runtime ABI. And there is another technology here that we won't talk about today, which is WRL, which is a standard C++ template-based way to do WinRT programming. My personal belief on this is I think if you're doing WinRT programming with C++, you should just use C++ CX. It's a lot easier than WRL. And I get people that kind of say, yeah, but I really want to be ISO. So I want all my code to be ISO compliant C++, and so I'd rather use WRL. And my philosophy is, well, if you're using WRL and you're using Windows WinRT APIs, your code is not cross-platform anyway. So you don't get a lot of advantages from writing ISO standard C++ kind of the hard way when that code will only run on Windows anyway. So given that it only runs on Windows, might as well write C++ CX. And we'll go over C++ CX in some detail. There's cool debugging support, show you that. If we have time at the end, I don't know if we'll have time, I'll show you how to package your application for the store, and how to deploy. All right, so let's just kind of jump in and look at some stuff first. That's usually the best way to start. Who reads the manual to start, right? You usually just jump in and do some stuff. Okay, so this is Visual Studio. I'm doing some A/B testing here today. Yesterday, I experimented by doing my presentation with the dark theme in Visual Studio. Today, I'm doing my presentation with the light theme in Visual Studio. So for those of you that have seen both, wondering what you feel as a presentation format. But, first thing I'm presented with, I choose File, New Project, and I've got a bunch of templates I can choose. Blank application, grid application, split app, DirectX app. And then I've got it I can do things like libraries as well that I can use from within the context of Windows Metro style applications. I'm just going to choose a grid application here for the heck of it. And it's generating my application. Here it is. So it's come up. I've got a bunch of boilerplate code that's automatically been generated for me. You'll notice this is a mix of stuff that looks like C++, standard C++, and it's a mix of stuff that looks like Pascal. Okay, I won't go that far, but it does use the hat character, and it reminds me of Pascal. And then over on the left, you can see some of the assets that have been created for me for my application. So here I'm editing my application XAML CPP file, and I can go in and I can edit the XAML itself. Take a look at it. I can even open these things in Expression Blend if I want to edit them. So while that loads, let's go back in Visual Studio and look at a little bit more about what I'm doing. Let me try and run this thing. So it's building. This being C++, it takes a couple seconds to build. It's actually much faster than it used to be. What you'll find, though, in 2010 is that build times are a little bit slower, tend to be a little bit slower for most scenarios in Visual Studio 2012. The irony is that the compiler's actually faster, but the header files grow. And so the compiler has a lot more work to do. There's a lot more template expansions. Windows.h is that much bigger. So it compiles more code, so the user experience is, wow, it's a little bit slower, but you should know the compiler is actually a little bit faster. All right, so here I just kind of this is my default template thing. This is touch enabled, does all the things that a nice Metro style application, good layout in a grid. I can select these things and it'll take me to more detail. So this is kind of a catalog or media consumption design template for this application. It's got navigation built in. So it's actually a pretty cool, fully featured little thing. Let me just get rid of it for now and stop debugging and head back over to Visual Studio. We saw a bunch of things that were in here. Let me head back on over to Expression Blend, and Expression may want me to build this thing. The other interesting thing about Expression is that it now understands C++, whereas before it didn't actually understand C++ code. So kind of a nice benefit now that we have C++ support in Expression. You can see I was able to build my C++ solution right from Visual Studio. And for some reason, it doesn't want to open my editor. So the reasons I would use Expression here is if I was doing some kind of advanced UI, I was doing animations, I was doing state changes, those kinds of things. If I had some fancy assets I wanted to include, Expression is kind of an IDE for designers. It's kind of for designers what Visual Studio is for developers. So let me head back here. And let's look at some of these artifacts in here. So one of the interesting things I have in here is I have a manifest, and it gives me an interesting manifest editor. And the manifest is a document that sits inside of my project that describes a lot of the attributes at a high level of what my project is and makes some assertions about how the Windows application subsystem should support my application. So I can say things like, okay, this is the name and the description. These are the supported resolutions, and is it supporting portrait, and is it supporting landscape, and those sorts of things. I can do logos. I can do a whole bunch of metadata about my application. I can do splash screens, that sort of thing. If I come back up, I can also talk about some of the capabilities that my application requires that Windows will need to offer for my application to behave correctly. So things like internet access, enterprise authentication, access to the microphone, access to location-based service APIs, all those kinds of things I can state here. And then in terms of declarations, you can see that I can use a bunch of things and specify properties about these things. And finally, I can talk about how my application gets packaged. So I can control version number, I can choose a certificate with which to sign my package, that sort of thing. All right, that's sort of the nickel tour of a XAML application. Let me shut this guy down and let me head back to the slides for a couple minutes. Let's try again. Hey, there we go. I have to push a total of 2 buttons behind here, and apparently that's too many because I can't really get it to cooperate with me. Let's see. Okay. Yes, good. Okay. Yay, I passed. All right, so C++ CX. I want to talk a little bit about that. If you saw my session yesterday, we hit at it on a high level. I want to drill down into the next level of detail beyond what I did yesterday. Essentially, it's a binding for a foreign type system for the C++ language. It's strongly typed. It's rooted in COM. So it's fundamentally reference counted, interface based, supports exceptions, and it has really great integration with STL. So if I want to use STL containers and algorithms, I can interoperate those things really well with C++ CX classes and types. It's also native code. So it's not that, this isn't JITted, this isn't, late compiled, late bound, anything like that. It's native code C++. So you get all the kind of benefits you know and love from native code C++. So at a high level, this is really the list of things that is C++ CX. I have ref classes, which represent reference types. I have value classes. I can have interfaces. I can have properties, events, and delegates. I can do generics. So now we have 2 ways to do parameterized types in C++. One is templates, and one is generics. Generics are the thing that you would use to expose parameterized types to the external world outside of your C++ code. If you were doing something strictly inside of your own C++ application architecture, I would still say use templates. But templates are not something that's consumable outside of a binary, typically. When I want to create a new one of these, I use ref new. And I can use the caret and the percent symbol as strong pointers and strong references. A lot of times we call it the hat. So where you might say, string star or char star or whatever, we would call it a string hat. One of the things I want to make sure you do not take away from this session is everybody run out of the room and stop writing ISO C++ and start writing C++ CX instead and go rewriting all of your application to use hats and blah, blah, blah. Like, don't do that. Where you should use C++ CX is on the surface area, where you have parts of your application or library that you want to expose to the external world. Do that in C++ CX. But the dark pieces in my little diagram here show things that I just write in regular standard C++. So all of my internals I'm going to write in regular standard C++. And then I'm probably going to surface APIs both in native C++. So if I have native C++ callers, maybe if I want my library to be multi-platform, I would surface it that way through a C++ API. And then if I wanted to expose it to the WinRT world, I would have a set of WinRT APIs that wrapped the C++ implementation. The advantage of doing that is that WinRT is consumable by theoretically any programming languages out of the box in Visual Studio. It's easily accessible from any .NET language, from C++ or from JavaScript. So you kind of get this great advantage of, hey, I can write everything in C++, I can wrap it with C++ CX, and suddenly my C++ library is now a every Windows programming language library. So it's pretty cool. So we'll talk a little bit. I want to go over several slides on kind of the details of C++ CX. First thing is the handle, or hat, which is a pointer to a WinRT object. This thing is automatically reference counted. So behind the scenes, when you instantiate one of these, when it goes out of scope, there are add refs and releases happening underneath the hood. So if you kind of dug in with the debugger, you would see add refs and releases happening. When the last release has happened and the ref count reaches 0, then the thing automatically gets deleted. There's no garbage collection, no GC. It's just simple reference counting. The code here shows how to create a new instance of a class called person. Use ref new, and then I work with this just like I work with any other C++ class. So I use object arrow member if it's a hat. Or if I'm dealing with it using stack semantics, I could use a dot. And rather than 0 to indicate that some pointer or some reference is unassigned, we use null putter, which you can use, of course, both in ISO C++ as well as in C++ CX. So this shows how I might define a class. This defines a class person with a constructor and a destructor. These classes, again, are ABI safe across all WinRT programming languages. The public methods of my class must use WinRT types. So I can't use, for example, I can't have a method that takes a std string if I'm exposing this as a public method of a WinRT class. Although internally, I could have private methods that use std string and use all kinds of C++ specific stuff, templated types, whatever. I just can't expose those as public members. Interfaces. So C++ has had interfaces forever. But interfaces in C++, I've always found a little bit wonky in standard C++, right? They're pure virtual classes, no implementation, but they're not necessarily a first-class citizen. There's no word to describe that. They're just classes without implementation. Now in C++ CX, there's a word. The word is called interface. So I can define an interface. In this case, you see some code that defines one called iAnimal. And you can see how I can instantiate one of these guys by instantiating an object that supports this interface or that implements this interface with ref new. And then I can call methods on it like any other class. I can inherit, I can do full inheritance, I can do all that kind of stuff. There's only single inheritance from one interface to another, so I can't have one interface that does multiple inheritance from other interfaces. I also can't have one C++ CX class that does multiple inheritance from other classes, but I can have one C++ CX class that inherits from multiple interfaces or implements multiple interfaces, which is something you would probably expect to see. So this shows a little bit about automatic lifetime management. You can see here I'm using stack semantics for this database connection object. So I use the dot operator to access members. You could see the little comment here, the destructor I don't have to worry about. As soon as database connection DB goes out of scope, it automatically releases or decrements the ref count. Ref count reaches 0 in this case, then it just goes away for me. That leads to one, cleaner code, but also fewer memory leaks, that sort of thing. I can also do properties. So properties are first-class citizen in C++ CX. Here you can see I've got a trivial property string at the top, and there's a implied backing store that gets created by the compiler, but I don't have to declare it, how this thing gets stored. I can also do user-defined getter and setter methods, and so you see that kind of on the middle of this slide, where I've got a get that returns a person hat and a set that accepts a person hat as a parameter. And then I've got this private member underscore sibling that I store as well. That ends up being my backing store. We also have delegates. So delegates, you declare these things like a function. So in this case, you can see I've got this thing declared, this delegate called property changed. Kind of think of it like a function type. So I can ref new one of these guys. I can then assign to it. In this case, I'm ref newing one, and I'm passing a lambda as the definition of that thing. And then after that, I can call p. You invoke them just like any other function, so I would invoke p like a function in that case. I also have events. So events have a type that's typically some delegate type. And these events can get fired when things happen. The WinRT Metro style UI framework makes extensive use, obviously, of events to tell me when buttons got clicked, when activation happened, when suspend happens, all that kind of stuff. And I can subscribe to those things with the plus equals operator. And so you see that down here at the bottom of the slide. I can save away that token, too, so that if I want to unsubscribe later, I can use the minus equals operator in order to unsubscribe from listening to an event. There's also exceptions. So you can throw exceptions if you receive or if you encounter an error condition. You can handle exceptions as well, as you would expect. Really, underneath the hood, exceptions are derived from H results. So when some COM operation fails, there's an H result, and that gets manifested in the language as exceptions. So platform : exceptions, kind of the root exception class, and if you try and catch that, you'll catch all WinRT exceptions. There's no state, and they don't travel across modules, and I'll talk more about that in just a second. And we don't recommend you derive from exception or any of the hierarchy of exception hat. We recommend you use the exceptions that are built into the system here. This shows what happens at the WinRT boundary. So if I've got two modules, I've got module A and B, and they're both WinRT modules. A is an XE, B is a DLL. So from within A, if I call module B's apple function, you can see that apple here throws. So what happens when it throws? Boom, when it hits the boundary, the throw ends, it becomes an H result. And that H result gets returned back to module A, and then module A rehydrates that H result as an exception. And then I can use that, I can do whatever I want to do to handle that exception. But just know that there's no stack unwinding or anything like that happening across module boundaries in WinRT. Fundamentally, it's just an error code that gets returned. In this case, I react to the exception by calling another function in module B called orange. And you could see orange calls this pair function over here in module A. It's a very incestuous relationship between module A and module B. So this calls pair, which maybe does something that causes an out-of-bounds exception to occur, which I can then catch over here. But what's happening in between is that it's an H result that gets returned. So I mentioned there's this other way to do parameterized types, and that's generics. Here's some syntax for how I would define a generic. So this is iPair, and it takes two types, first and second type. And you can see how I've implemented this thing as a string URI pair. So I can say, okay, I've got this thing, and it's a string, and it's a URI, and then at the bottom I instantiate this. I can assign to the properties. So it looks like C++ templates. Very similar syntax. So if you're comfortable working with C++ templates, if you're comfortable working with .NET generics, then you'll be comfortable with this as well. How many .NET folks, by the way, in the room? A lot of folks do .NET. Who only does C++? Now you have me curious. Few hands. Okay. Yeah. It's funny how like one guy like, and then other people are like, yeah, okay, all right, me too. All right. So how does one WinRT module know about the types and functions and everything in another WinRT module? It's through metadata. Metadata is contained in WinMD files, and you can consume it in a couple different ways. One is to do pound using in your code and pass in the components WinMD file that has all of its metadata. The other is to add a reference in Solution Explorer and Visual Studio. When you have a C++ module, C++ exe or DLL or whatever that exposes public types, those will automatically get put into metadata. So you don't have to take any particular action to like create this thing. It gets created for you. But it's important that you know that this is how it's a separate file, and this is how one module in WinRT knows how to get at the types in another module. We also have partial classes, which C++, standard C++ does not have partial classes. .NET has had it for some time. Partial classes are really handy if you develop developer tools. And that's kind of the primary use case scenario for a partial class is a developer tool where you have my user class. I want to be unpolluted by whatever the IDE is doing to create my forms and members in the forms and applications and all that. So this allows the IDE to work in its own little safe envelope on a part of the class, and allows you as the user to work on your part of the class without you editing the code, and then the IDE can't figure out how to deal with your edits, or you just having to paw through all of this code that the IDE needs as a part of its definition. So that's it on C++ CX. There's a whole bunch more there, but I just kind of wanted to give you guys the basic primer so you understood some of the code that you're going to be looking at. Let's talk about XAML. How many folks have been doing XAML, first of all? Let me kind of level set. Okay, most of you here, so I don't need to go into too much detail on XAML itself. XML-based language for declaratively setting up user interfaces. We saw that I can have a designer experience inside of Blend. I can do XAML coding inside of Visual Studio, like it's XML documents, so I can edit it just like I can any other XML document. It's got a bunch of user interface controls in the box, so I can kind of drag controls and have my typical form designer experience. I can also create custom controls or acquire custom controls that other people have built and use those in my software. How XAML connects to your code. So for example, if I have in my XAML, let's say a form XAML document, here I'm creating a button and it's got a height and a width, and I'm assigning a handler for the button click event. It generates some C++ code for me. So that XAML document physically goes through a XAML compiler. That XAML compiler emits C++ code. And then that C++ code is compiled and linked into your application. So it's going to create this C++ code that's going to instantiate the object. It's going to set a bunch of properties on the object. It's going to assign to the event handler, et cetera. Although I don't have the event handler assignment set up in here. And then in my C++, the other part of my partial class, my C++ code, I can just, like, for example, have a button handler method that I can use to handle the click. We also have data binding. So here's an example of data binding. What data binding allows me to do is easily bind controls to some external data source, so that when this data changes, the control automatically gets updated for me. I don't have to do anything to update the contents of the control. So this shows some code for doing that. I decorate this particular class with the Windows UI XAML data bindable attribute. And then you can see in this property here, I've got this property which is a string. It's called title. And in my XAML code, I can use this markup here that says binding to the path title. And that will automatically bind those two things together. So let's look a little bit more at this in demo form. Let's see if I can get this switch over right this time. I'm sure I can do it. Yeah. I knew it would take a little time, but I knew it would eventually happen. OK, so what I have here is I've got a little application I've built, or actually someone on my team built, called XAML Face Finder. And so the application's pretty straightforward. I want to do some data binding with it. I want to do some other things. Let's take a quick look at the application just to kind of see what it is. It's OK. So I've got this form, and I can run it. And sometimes that's the easiest way to see what something is to run it. So while this thing builds, you can see that I've got a main page here, and that's pretty much it. I don't have a ton of code associated with it. Here's the application. The application has two buttons, one to load photos and one to detect faces. Right now, these buttons aren't wired up to do anything. So when I click them, it's terribly uninteresting. But let me go back to Visual Studio and make those buttons do something. So here we are. We're back in VS. We're looking at the XAML editor. So if I wanted to edit my page here, I could do that. Instead, I'm going to head over to my CPP code. There we go. So here's my main page CPP code. And I've got three methods that I want to do some things with. I wanted to start with sort of a pre-built application here, and then we'll kind of build it up together so you can see how this thing evolves. Some of these methods are a little bit involved. So rather than forcing you to sit there while I madly type away trying to make no errors, which happens extremely rarely, I might add, I'm just going to paste in some code, and then we'll talk about what's happening as I paste in some code. So the first thing I've done is I've pasted in some code for the load button. When I click the load button, this is what happens. And what this does is it opens up the file open picker. It allows me to select a file. And then as I select a file, you notice that this is an async operation. So the picker opens. It's an asynchronous operation. So I'm wrapping that asynchronous operation up in a task. The type of the task is a vector view of storage files. A vector view is an interface I can use to get at the contents of a vector, but I don't have to have the actual vector object. I can just have this read-only view of it, and that's what this returns. And then I iterate over the files that they picked, and I add them to a list. It actually gets copied into a temp directory, and I add them to a list. And so pretty straightforward. Let's see. If I just run this, let's see what my application does. So here's my application. I'm going to bring up load photos, and great. OK, so now I can pick some photos. David Beckham, very handsome man. So there we go. So it loads some photos. I've got a grid here in my application, so I'm displaying each of these photos in a grid, or in a grid view. It's the Mac and the PC guy. That's good photos. All right. So I can load them, but I can't do anything interesting with them yet. So what I want to do now is I would like to do this cool face detection thing where when I load some photos, I want to click the Detect Faces button, and I want to go through and find all of the faces. This is how I might have some technology that allows me to tag photos and that sort of thing. I have one problem, which is that I'm not a computational image management expert, so I'm not really good at writing face detection algorithms. But what I am really good at is Bing. So I found a face detection algorithm on the web. I found a library on the web that I could use, and so I'm consuming that here. Let me add a reference to that library. So this library is built as a Visual Studio extension, and you can see I've got a couple of them here. One is WinRT and one is C++. I'm going to choose the WinRT one, which is the C++ code with the WinRT. It's all C++ internally with the WinRT veneer over it. So let me select that. Say OK. And say OK again. OK. Now, the other thing I'm going to need is I need some place to display the faces. So I think to do that, what I'll do is I'll add another grid view. Let me copy out here. another grid view. And what I'm going to do is I'm going to add this directly into my XAML code. So if I look at my main page XAML, here it is. And so I'm just going to paste it. Boink. There we go. So what I have is I had this grid view called input grid view. I was binding it to this thing called input file list. And we'll take a look at what that is in a second. I've added a second one, which looks almost identical. I'm calling this one face grid view. So the top grid view is input file list. It shows me all of the files. The face grid view is another grid view on the bottom that's going to show me all the pictures of faces that get detected. And I did a couple, you might notice a couple changes here. One is the row property is 2, so it's below the upper grid view in the user interface. I'm binding this one to something called image. The images are bound to something called image. The grid view itself is bound to something called face file list. And I'm allowing multiple selection in this case, whereas in the top one, I'm not allowing multiple selection. I'm not allowing selection at all. So that's the extent of the changes I need to make to my UI. Let me now go change my C++ code. And I'm going to add one more method here. I'm going to fill in the detect button click. Okay, so we'll paste this guy in here. And so a couple things I want to point out. One is, before I paste this, notice that input file list and face file list are here. They're just two vectors of object. So those are the two vectors that are my grid data bind, my two grids data bind to. They're public, so it's able to look at those. Now, if I go back and look at the code that I just pasted in, again, pretty straightforward. Fits on one screen in large font, so that means it's straightforward. What I do is I create a new instance of this WinRT face detect component. That's the thing that I pulled in via extension SDK. And then I pass it this list of files, and this thing does the magic to go through this list of files, find all the faces within those images, and then gives me back another list of files, which is little thumbnails of all the faces that it found. And then I've got some code at the end here that simply just waits for that operation to be completed so that this method doesn't exit until the asynchronous copying and searching has been completed. All right, so I did all that. Let's save our work, which is always a good practice, and let's run this guy. There we go. So it's building. Again, compiles pretty quickly. Here we go. Okay, so the UI is still very plain. Let me now load some photos here. We'll go here. We'll just do select all, show me everything. Then we'll say detect faces. And oh, look, so now it's running and it's starting to asynchronously. And you can see that all of these operations are asynchronous. So you can see the photos kind of showing up as they become available. Happens automatically for me. One, the file operations are asynchronous. And two, the data binding just automatically looks. And as the vectors fill up, the grid views are able to just pop those directly into the user interface. So that all looks pretty cool. Lots of faces. Let's see. What do I want to do with these faces? There are some interesting things I could do with these faces. For example, I could search for them. So for example, if I were here and I wanted to search for, like, I don't know, friend. Okay, well, I can't find anything. So I wonder how I can make that work. Let's get rid of this guy. It turns out that was kind of a leading statement, obviously, because I want to show you how to make that work. So on this onData, what I need to do is override this page's onDataRequested event, and handle that event so that when search starts looking for things in my application, I know how to offer up data to it. And let me show you. OK, so here's an example of my cold medicine kicking in. I said search. What I really meant was share. So as I bring up the charm here, Yeah, what I would like to do is be able to share. I would like to be able to click on some of these, and then I would like to be able to share them. So let me bring up the little charm. Come on, little fella. It's a little bit more challenging with the mouse than it is with a touch screen. And there we go. I don't have anything available for sharing. So that's what I'm going to implement. I want to implement share. I want to be able to take some of the things that I've selected here and just kind of share them out. So let's do that. I've got some code that does that for me. Let's take a look at it. Okay, so here we go. As it requests data, this allows me to share. So what I do here is I look at all of the selected items, I put them in another vector, and then I send that out via an argument that gets passed in as a part of the request. One of the things that it allows me to do is set the storage item, so I pass it that vector, and then that becomes automatically available for sharing. So I've just copied that in there. Now let me run this guy. And all right, so let's see what it does now. So now we can load some photos here. We can detect faces in the photos. Sadly, it only shows 5 of 6 friends' faces. Apparently, the algorithm does not like Chandler's face. I'm not sure why that is. Maybe he's not human. I don't know. All right, so now, it's nothing to share now, but let me select some things here. Maybe we'll just select Ross. Okay. So there it is. It picked up the fact that I have Ross selected. And it picked up applications that handle this contract. So I've got the sharing contract where applications can offer data via a certain format by contract, and then applications can consume that kind of data via contract. So in this case, mail might work. You might want to share this via email. So it opens up my mail for me. I can send this to myself. There we go. There's me. And subject, Ross, yay. And then we'll hit send. Okay, so allegedly that sent some email. If it worked correctly, I should have in my inbox, there it is. I can see it came up in my email just now. And if I click on this, there's my picture of Ross. So that was good. I enjoyed that. So that's okay. So we've built a Metro-style application. We've managed to load some images. We've managed to do some face detection. We're able to share those. Now, I mentioned earlier search when I kind of jumped the gun on myself. Let's look at how I might do that. So search is also a contract, but in this case, it's a contract that it's a service that I need to offer. It's one that I need to implement. And Visual Studio has some helpful ways to enable me to do that. So on my application, I can add a new item. And if I select Windows Metro Style, there's a whole bunch of stuff as a part of this new item dialog. One of the things that I can add here is a search contract. So great. Let me go add that. Okay, so it's adding my search contract. That's going to come in the form of some code and some UI templates. So what this does is this gives me a starting point for UI. It creates the grid. It does everything for me that I need. All I need to do is go look for the places where Visual Studio leaves comments that says, "Hey, you need to go put your code in here in order to respond to search." So let me do that. First place I need to, well, first and only in this case, I need to put some stuff is in the load state. So let's see. Okay, great. There's this load state thing. I see it here. Load state actually has some stuff that it starts with that I don't want or need. So I'm going to delete some of these things that set some properties on the view model. And then I'm going to add some code here. So some of the code I inserted, you can see it's maybe just 7 lines of code here. I load up the face detect component. I look at the files that are associated with the component, and I search through those files looking for a match. And when I find a match, I add it to the search results. Pretty straightforward in terms of code. So let's see. Can it really be that easy? Maybe. We'll see if it works. Okay, so it seems to not want to. Oh, I missed a brace somewhere? Ah, at the end of this method? I deleted it. Ah. It's always good to have a room full of compilers that can help these things. Everyone's a compiler. I'll be honest, it would have taken me forever to figure out that I'd forgotten the closing brace, so thank you. All right, so let's load some more photos again. Let's go back to our friends, the friends, and let's detect some faces. So good, found some faces. That's good. Let's now use search. And now, if we do this, hey, look, it found the images that have the file name friend. So great, now I'm interoperating via contract with search. My application's kind of looking good. It's looking like a real participant in the Metro world. Feeling pretty good about that. Let's see here. Feeling less good about that, but that's okay. We'll shut it down. You know, I always say if it didn't crash, we would be shipping it now. And the truth is we're not shipping Visual Studio quite yet. So soon, though, soon. And I've got an older build installed on this machine as well. All right, so a couple of other things I might like to do. Let's take another look at this guy. So if I load some things, you saw that inside of this file open picker, I was choosing things that were in my files directory under my user account. But you could see that there's a contract here, a file open contract, that I can actually open things via application, not just via some file on disk or in the cloud or whatever. For example, I can also acquire image with a camera. So if I selected camera, there's me. Take a picture of me. See, that looks like a picture of me. If I do that, OK, and then open this, I would be able to use this as a part of face detection. I was having a little bit of trouble with this earlier. Let's just give it a whirl. If it crashes, we'll just keep going on like nothing happened. Oh no, it works. So unlike Chandler Bing, I'm human, apparently, because it found my face. So that was cool. What if? But my application handles images as well. So what if I wanted to put my application in that little file picker thing so that people can acquire images also from me? Let's try that. So let's run back to Visual Studio here. And there's another contract that I can implement. I'll right-click here. And I will add a new item. And I will add a file open picker contract. So it's going to do a little bit of work. Again, it creates everything for me. There's a bunch of boilerplate code. There's some user interface that it creates. I don't have to do a lot there other than find the right places in the source code to insert what I need to do. And there are only a couple places here. So one is inside of the activate method. There's a little work I need to do inside of the activate method. So here we go. Here's activate. It even was nice enough to leave a little comment for me. Hey, this is the place where you do your thing. So let me insert the code. And you can see I come up with a vector that's a list of my files. I fire up the WinRT component, that is the face detector. And I call search files, looking for a face. And then I add those to a list. And then that thing gets inserted. So that's about it. Pretty straightforward. OK, so that's one piece. I also need to add some code in one more place, which in this case is the selection change. So I need to understand when the selection changes, and I need to activate. So let me Let me copy that out. Here's selection change. And again, there's a big to-do here. So I need to know when to update the Windows UI with add file and remove file. So you can see I'm doing that. Get the selected items and then add the selected items to the list. And that's about it. All right, so let me run this guy. There we go. I didn't miss a brace that time. Let's again go with friends. Seems to be a good theme. Let's detect the faces again. Okay, so that's all good. Seems to work. I didn't break anything in my code anyway that I can find. But this isn't what I'm looking for. What I'm looking for is I would like to be able to go to email and maybe consume this this contract. So let me send myself an email, and then let me attach. And instead of the camera, I have my XAML Face Finder, the application that I'm building here. And there they are. So if I wanted to send more pictures, if you guys all get pictures of Ross from me, you know I've got some sort of unhealthy obsession. Okay, so good. All those things seem to work. I've got the data binding. I was able to implement some contracts. I'm going to head back to the slides. I think I'm going to head back to the slides. We'll see what the box here allows me to do. There we go. Yes, I am heading back to the slides. So we can talk a little bit more. In particular, what I'd like to talk about is hybrid applications. Hybrid applications allow, we call it the best of both worlds because it allows you to use C++ where it really matters, where, in some core WinRT component where you really need the performance, but then stick to some higher level, stay in some higher level place to do my UI. So I can do my UI in HTML and JavaScript. I can do all my code behind in JavaScript, and then I can just call into these C++ authored WinRT components. Of course, everyone is doing it. Bunch of applications that are built into Windows are written exactly this way, with user interface being built in HTML, all the code behind in JavaScript, calling into C++ WinRT components. How do I do it? Well, I just need to reference that WinRT component that I've built. A couple ways I can do that. I can do that through extension SDKs, which we already saw, or I can do that through project references, and we'll take a look at that, kind of a similar variation on the theme. And while I'm doing these mixed mode projects, I get full IntelliSense, I get just a very supportive application development environment in this mixed mode, and I can choose to debug either the JavaScript code or the native code if I want to debug this stuff. So with that, let me switch over and let's try and do some JavaScript. Okay, how about now? Ooh. Okay, stay. Good. Okay, we'll just close out this solution, and we'll open another one. We'll open the HTML Face Finder in this case. Okay, so here's my application. It's an HTML application. I don't have any C++ in this application right now. So if I open it, what do I see? I have a default HTML. So this is the HTML document that represents my interface for my application. You can see if you look at this, like, wow, okay, I've got some list views, and I've got this app bar, and inside of my app bar, I've got a couple buttons. Those happen to be my load and detect buttons. So the UI for this thing looks exactly like the UI for my, or very close like the UI for my C++ application. I've just written it strictly in HTML. So let's see if I run it. I get a bizarre error. Fascinating. All right, when all else fails, let's close Visual Studio. Let's reopen. And then we'll try again. Fear not, I have one more trick up my sleeve, which is I have another copy of this project. So let's see if that works. Okay. What kind of odds will you guys give me that this thing works? Nobody's taking odds. Hey, it works. All right. Not sure what that was, but luckily we got through it. So what I did is I went to a copy of in my project directory where it's already I've already made the changes to make the application work. So initially, my HTML document, I had nothing wired to the Detect Faces button. I had loaded images lined up, and I could go ahead and choose images just like the other user interface that I wrote in XAML. But I had not yet wired up the connection to my WinRT component. So I want to show you how I did that. Now I'm doing it looking at something that I've already completed. So what I did is I had a project that was just my HTML face finder. I added the WinRT component project as a part of the solution as well. So to this solution, I was able to add an existing project, and I happen to have a project right here, which is the WinRT Face Detect component. So that project is now a part of my solution, and in fact, the code for it is right here. I can open up the C++ code here, and what you see is this is the outer thing inside the implementation. It's written just in ISO C++, but as an outer API, it's surfacing the API to the world as C++ CX. You can see inside the implementation of these classes, though, I'm doing std vectors and std strings and all that kind of regular C++ stuff. All right, so that's how I'm surfacing this out to the world. The other thing that I did is added a reference. So previously you saw that I used the extension manager here in order to add a reference to the WinRT SDK. Rather than doing that, I added a solution reference. So I said, hey, this HTML project references the WinRT types that are in this other project in my solution. So I added those things. And now when I run this thing, great. So face detect still works. So now I've done this kind of best of both worlds application. Everything's in JavaScript. Let me show you the JavaScript code I used to invoke the extension. It's actually pretty straightforward. So if I come over and I look at my JavaScript here, as the debugger closes down. So in my detect faces, just really two function calls. One is I instantiate the WinRT component, so new WinRT face detect. And then I use that. I call extract from files async. And I pass a few Lambda expressions. This is kind of the JavaScript syntax. Most importantly, I pass the progress handler. And inside of this progress handler, this add path to list, every time I get new progress, I can handle that new progress by taking that image and adding it to the list, and then it populates itself on the grid. So pretty straightforward. That's all I did. My other JavaScript method is the load images, just to show you some JavaScript code that looks very, very much like the C++ code I wrote to, based on whatever directory you've chosen, help you extract all the images and put them into a list. One of the things you'll notice about JavaScript, for example, let me see if I can get IntelliSense to come up here. One of the things you'll notice is that JavaScript uses this first letter lowercase camel cat kind of style for how coding is done. So what you will find, especially if you're someone that is accustomed to thinking that case sensitivity is important, you'll find cases where, hey, I wrote this C++ component where I know the first character of that type is uppercase, but then when I get my help and pop up IntelliSense in JavaScript that looks like lowercase, the answer is yes, that's true, don't panic. That's just the way it looks like, so it looks comfortable for JavaScript. That's the way that the JavaScript folks chose to project WinRT to JavaScript, because it makes WinRT types look more at home and more natural in the JavaScript environment. And by the way, if you want to go into like how do I spelunk in and kind of figure out what are all these WinRT things? What's all this stuff in Windows that's available to me? Object Browser is a good place to go if you want to do that. So for example, I can use the Object Browser, and then I can start spelunking Windows WinMD files, all their metadata, and I can learn everything there is to know, or at least in terms of its public-facing API, I can learn what there is to know about all the things that are inside of Windows. So for example, I can drill down, I can drill into application model, et cetera, et cetera. I can select any of these guys. So I can select an interface. It tells me the methods. It gives me a little bit of information. It tells me what attributes are used to decorate that type. So the object browser is really your friend when you're trying to explore some collection of types that you don't know a lot about. When you're coding and you're on a type that you want to learn more about, you can put the cursor there, hit F12. If you don't have source code, it'll generally take you to the object browser to go learn more about it. Only one more thing I wanted to hit on with you guys, and that is stuff around a little bit about deployment. Just more of an FYI. So deployment's different in the Metro-style world. In particular, it's not like desktop applications where I build my app, creates an exe, I take that exe, I go run it on some arbitrary other machine that runs Windows. The model's a little bit different than that. If I go back to the application I was working on, let's go back to XAML Face Finder. Okay. The model is fundamentally based on the idea that applications, Metro-style applications, will be deployed via the store, the Windows Store, so that kind of like a shopping experience that you would recognize if you're familiar with the app discovery and purchase experience for a phone. So I would go to the store, I would find the application I want, I would buy it or download it, maybe it's a free app, and then that would automatically pull the application down and deploy it on my machine. But what if I'm in an enterprise, or what if I'm a developer and I want to test this application on multiple machines, or I want to what you would call sideload this application onto some other machines so that they can run in my enterprise? What we would do here is create a package. And in this case, I'm not going to want to upload it to the store. I just kind of want to let you guys know. So I can specify some information. This is the same interface that you recognized out of the manifest editor, where I could say, OK, well, this is the version number I'm working with. I can choose which configuration I want to deploy. And then I can say create. And then it will create a package for me. That package includes a bunch of files. Interestingly, no exe, but a bunch of files together. I can take that package, move it to another machine, and the package also comes with a PowerShell script that I can use to install that app. I run that on the target machine. I can install that application. I can also get applications to other machines in different ways. For example, via the debugger, I can do remote debugging, and that will, once I've got something running on another machine, that will help me connect to it and debug it. Debugging is also interesting in that there's a simulator. So what if I'm building, here I have a laptop, it's non-touch screen, but I want to build an application that is really designed for a tablet. In that case, I can use the simulator debugger, which on my build is very wonky, but I want to show you at least what it looks like. So I can choose simulator debugger, I can say go debug, and what it will do is it will fire up the simulator, which is this guy, which looks like a tablet. And then I can use the icons on the right to control all kinds of attributes about how I might want to test my application on what it would be like on a Windows tablet form factor device without having one. So I can kind of, there are controls to like do different things with touch mode and pinch and zoom mode. I can change the orientation, so I can do different things with orientation. Changing resolution, changing my location. So if my application uses some location-based services, I can manipulate that as well. So kind of one-stop shopping for being able to debug this in kind of a true-to-life environment. And it's indeed wonky on my machine, so I'm not gonna continue to try and drill in and make this guy work. Let me. Wow, see, that was easier. That I only had to push the button one time that time. Okay, this is the majority of my content here. What I hope you take away from today is that C++ helps you prepare your applications for Windows 8 for building Metro style. You can either write the whole thing in C++ if that's what you want to do, or you can write the most critical pieces of your application or performance-sensitive pieces of your application in C++, and then use HTML and JavaScript to build the user interface as a higher-level language. All three application models are supported, which we talked about earlier. And you've got all the designer support built into both Visual Studio as well as Expression Blend. And with that, we have about 8 minutes left. Happy to take any questions. Yes, sir. Is
there a way to interact with real.NET assemblies like with C++ CLI?
Yes, you can use C++ CLI. You cannot use both C++ CX and C++ CLI in the same module because the syntax is the same, practically. Very, very similar, right? In one case, you ref new, in one case, you GC new, but they both do hats and all that kind of stuff and interfaces and generics. So you can use them both in a single application. You just have to have, you have to choose on a source file by source file basis which ones you want to support CLI and which ones you want to support CX. Does that answer your question?
So you would get the bridge through regular C++, for Metro or RT, sorry, C++ CX, regular C++, to C++ CLI, and then to .NET or C#.
Yes, if you wanted to do kind of the round trip interop that way, you could do it that way from C++ CX to C++ to C++ CLI to .NET. There might be more direct routes. It depends on what you're trying to do. Maybe it might make sense to just use C# for that part of your application and make that a C# assembly. And C# and the .NET languages talk natively to WinRT. So you don't have to do this kind of long round trip interop to interop to interop kind of thing. And then that would probably be the way I would do it. But again, it depends on exactly what you have source code for and what you don't have source code for, and how your libraries are constructed and that sort of thing. Other questions? Yes.
Could you explain a little bit about how type marshalling is done between C++, CX, and normal native types?
Type marshalling?
Yes. Let's say you want to make a vector out of the simplest example.
Okay, yeah.
Vector.
Yeah, so I showed a little bit about this yesterday. I didn't show up my slides today, but STL is the primary example of where you've got a bunch of WinRT types and you've got C++ types, and you need them to talk to each other because you want to expose yourself to the world as WinRT, but your implementation of your software is probably standard C++. For that, there's a header file, collection.h. Where all the conversions happen. So you can literally go open up that header file, you can go read through that header file, and you can see how we do the conversions for things like the platform collections vector to the std vector, and the platform string to std string and stdw string. All that stuff is in there.
Does that involve copying or not?
I believe it necessarily must if you're doing like, for example, you have a vector of platform string and a vector of std string, like it must necessarily copy because they're actually physically different things. I can't think of a case offhand where they're not physically different things and therefore requiring copy. So yeah, integers, yeah, those are rather inexpensive to copy.
Yeah. Depends on how many of them.
Yes, that's true. Other questions? Yes, the question was, you did search and share. Do those things get linked together so that I can independently search for something and then share the findings of my search? That should work. You should be able to multi-select and then be able to share those things. Yes. I'm sorry? Yes. Yes. Search will still work even if the application is not running. That's correct. Yes. In that case, I started in my application, so the application was still running. But in the search case, my application doesn't necessarily need to be running. Yes. Yeah, so I mentioned reference counting. I didn't talk a lot about garbage collection, and that's true. There's no garbage collection in WinRT, unless you're doing .NET with WinRT, in which case the .NET side is garbage collected. But WinRT types are regular native code objects. They underneath the hood, if you were to look at one under the hood, it would look like a COM object with a reference count and a query interface, add ref and release and all that kind of stuff. And they don't get marked and swept or GC'd or anything like that. Like literally when ref count goes to 0, they get freed. And yeah, one more question.
You showed some example of data binding. And you data bind to WinRT type.
Yes.
Can you data bind to the C++ type?
I cannot. So when I do data binding, I have to data bind to WinRT. Yes, I have to surface, expose my external facing surface area as WinRT so that the rest of the system understands it. So I wouldn't be able to data bind to like a std vector. Yeah. All right, that's about it. Thank you very much. I'll stick around if you guys have questions afterward, but enjoy the last day. Thank you.